Welcome back to Scholar Strive, doing some math. Today we'll be working with solving radical equations. That's just like solving normal equations, trying to get x by itself, but this time we're going to have radicals with different exponents, fractional exponents, whatnot. This is how it works. So we got example 1 here. Isolate the radical. That's our first step. So our radical is x minus 4 to the 2/3. Isolating it by getting rid of that negative 9 there, so adding 9 to both sides, and I get 25. Okay? So this radical here, x minus 4 to the 2/3, can be written in two different ways. It's either x minus 4, we have the square root here, and then this gets to the third power. So what you do is you do the square root first, and then take it to the third power, or you do the inside to the third power, so this is x minus 4 to the third power, and then you do the square root. Either way works, but in this case we're just going to leave it as a fraction, because to eliminate our radical, to get rid of it, to get rid of 2/3, we're going to take it to the power of 3/2. What we do to one side, we must do to the other. So why we do it to the 3/2, all we do is flip the fraction. It's because when they multiply together, all we do is get 1, and then it cancels each other out. Okay, so 25 to the 3/2, I'm going to use the first method here, which is the square root of 25, and then I'm going to cube it afterwards. Okay? Now, because my root is even, I'm going to have two answers. So let's simplify this a little bit. X minus 4 equals, so what's the square root of 25? That is plus or minus 5. And then we have cubed right here. So the square root of 25 is plus or minus 5. And then we're going to do cubed. Okay, so we're going to have two equations. So we have x minus 4 equals 5 cubed. And x minus 4 equals negative 5 cubed. Okay. So I'm going to add 4 to both sides. 5 cubed is 125, so 4 plus 125 equals 129. And then this is going to be negative 125 plus 4, so this is going to be negative 121. Okay. So we have two answers. Now we're going to check for extraneous solutions. And basically we take our two answers, plug it into the equation, the original equation, and see if it works. Okay. So back to example 1. X minus 4, so 129 minus 4, that's in parentheses, to the 2/3, minus 9 equals 16. So we're going to see if this is true. And then over here, negative 121 minus 4 to the 2/3, minus 9, does that equal 16? Okay. So that's going to be 120 over here, and my root is cubed, right? Wait. So our root is 3, so this is the cube root of 125, and then we're going to square it. Minus 9 equals 16. So this becomes, the cube root of 125 is 5. 5 squared is 25. So 25 minus 9 Does that equal 16? 16 does equal 16. So back on the right. Minus 121 minus 4 is negative 125. To the 2/3 minus 9 equals 16. So we're going to do the cube root of negative 125. And then we're going to square it. Minus 9 equals 16. So this becomes negative 5 squared minus 9 equals 16. 25 minus 9 equals 16. 16 does equal 16. So there is no extraneous solutions. All right. Let's move on to the next problem. All right, number 2. So we're going to isolate the variable. Ooh. So there's x's on both sides. So what do we do here? We're still going to add 2. Because we're still going to isolate the radical. X minus 6 equals x minus 8. Because that's negative 10 plus 2. Okay. And then we're going to eliminate the radical. So to get rid of the square root, we're going to just square both sides. Now when we square both sides, just put this in parentheses and then square. Okay? So I get x minus 6 equals, and a lot of you guys have been having trouble with this. When this is squared, remember, that means there's 2 of these. Okay? And we're going to have to FOIL. So it's not x squared minus 64. It is x squared minus 16x plus 64. Okay? Where I got the 16x from is minus 8 times x minus 8 times x. Okay, next thing we're going to do is move everything over to one side. Because this is starting to look like a factoring problem. Or a quadratic equation. Okay. So I'm going to add 6 and subtract x. So I'm going to get 0 equals x squared minus 17x plus 80 or 74. Or, sorry, 70. Okay. And then this can be factored. X minus 7. X minus 10. So we have 2 solutions. X equals 7. X equals 10. So we're going to plug these both into the equations. Make sure that it works. Okay. So this side, left side, I'm going to use 7 minus 6, which is the square root of 1. So I have 1 minus 2. Does that equal 7 minus 10? And we get negative 1. Oh. Negative 1 equals negative 3. Which obviously, this doesn't work. So x equals 7 is extraneous. That means it just doesn't work. Okay? It's not a true solution. So I'm going to try x equals 10. So I have 10 minus 6 square root, and then minus 2. Does that equal x minus 10? Which x is 10, so 10 minus 10. So 10 minus 6 is square root of 4 minus 2. Does that equal 0? 2 minus 2 does equal 0. So that one works. Okay. Alright, next one, example 3. So we have 3 times the cube root of 16x, and then minus 7, that's outside the radical, equals 17. So first thing we do, isolate the radical. I'm going to add 7 to both sides, and I get 3 times the cubed root of 16x equals 24. Okay, and then that, to get rid of the 3 outside, just going to divide both sides by 3. So I get the cubed root of 16x equals 8. Okay. So to get rid of the cube root, I'm going to cube both sides and get 16x equals, that's some big number, calculator, 512. Divide by 16, and x equals 32. And then check it. So 3 times the cubed root of 16 times 32. And then we're going to subtract 7 afterwards and see if that's equal to 17. Okay, so inside the cube root, we get some big number, 512. And then minus 7. Cube root of 512 is 8. So 3 times 8 minus 7. Does that equal 17? 24 minus 7 does indeed equal 17. Alright, next one. Oh, look at that. Cube root of 12x minus 5 minus cube root of 8x minus 15. Luckily, they're both cube roots, so I'm going to move one of them over the other side. So cube root of 12x minus 5, moving the other one over. So I'm adding a cube root of 8x minus 15. Pretty big there. Okay, and then to get rid of the cube root, I'm going to cube both sides, so that's why it's lucky. So they both cancel out, and I'm left with 12x minus 5 equals 8x minus 15. So add and subtract stuff. So I get 4x on this side, and I get negative 10 on this side. So x equals negative 10 divided by 4, which, if I reduce that, negative 5 halves. Okay, now we're going to plug this back in. The cubed root of 12 times negative 5 halves minus 5. Minus cubed root of 8 times negative 5 halves minus 15. So in here, negative 12 times negative 5 is negative 60. Negative 60 divided by 2 is negative 30 minus 5. And then in here, 8 times negative 5 is 40. Divided by 2 is negative 20 minus 15. And these are cube roots. Cube root of negative 35. We're allowed to have that because it's cubed root. Minus the cubed root of negative 35 does indeed equal 0. 0 equals 0. Something minus itself is 0. Alright, next problem. Okay. Well, this is terrible. We're going to go ahead and just square both sides because we have a square root on both sides. Moving that 1 anywhere is not going to help. Okay. So this is what it's going to look like. I'm going to square both sides, so I'm using the equation up here. Squared. Squared. So that is the same thing as the square root of x plus 2 plus 1. Square root of x plus 2 plus 1 equals 3 minus x. And we're going to FOIL this over here. Okay, so the square root of x plus 2 squared is going to be x plus 2. And then, so that's that. And then we're going to do this, which is, well, easy, because anything times 1 is itself. Okay, and then, so we're going to do plus. And then that's going to be another 1, so there's 2 of them. And then 1 times 1 is 1. And then we're going to do 3 minus x over here. Gonna simplify a little bit. X plus 3 plus 2 square root of x plus 2. And then we have 3 minus x. Okay. And since I'm down to 1 radical, I'm going to move everything to the right side and try to isolate it. So I'm going to subtract this 3, I'm going to subtract this x, subtracting x, subtracting 3. So I have 2 times the square root of x plus 2 on the left equals 3 minus 3 is 0, and then we have negative 2x on the right. I'm going to divide by negative 2. And get the square root of x plus 2 equals negative 1 x. So just negative x. And then I'm square both sides. Again. So x plus 2 equals x squared. Well, now I'm going to move everything to one side, because we have a quadratic going on. So x squared minus x minus 2 equals 0. Hopefully that factors. Yes, it does. Into x minus 2, x plus 1. So either x equals 2 or x equals negative 1. Let's check. Plug them back into the original equation. First, I'm going to start off with 2. So we have the square root of 2 plus 2 plus 1. Does that equal the square root of 3 minus 2? No, it does not, because we're going to get square root of 4 here, plus 1 is 5. Does 5 equal the square root of 1, which is 1? No, it doesn't. So x equals 2 is extraneous. Oop. Extraneous. It's up top if you want to look at the spelling. Anyways, let's try x equals 1. So that means we'll get, or negative 1. So we'll get negative 1 plus 2 plus 1. Does that equal 3 plus 1? And I can't write it for some reason, so I'm just going to continue. Does the square root of 1 plus 1 equal the square root of 4? 2 equals 2, so that works. So your true answer is x equals negative 1. Your extraneous solution is x equals 2. Alright, that's all for today.